Yes, class. So let's start with the lesson 2. See, class, today we couldn't have the 2 hours class because otherwise the class had to start half an hour early. So today there was a clashing between the classes. So today we'll have a 1.5 hour class only. From next time onwards, we'll have proper 2 hours class.
Ma'am, last chapter is over.
Last chapter is over. Where were you, Fia? EMI,
No, ma'am.
AC also we had started. You were so eager for the extra classes. Now you are not attending them, Fia.
No, ma'am, I couldn't attend today. I was out. I'll see the recorded lecture, ma'am.
All right. See, class, let's start with electric potential now. So electric potential and capacitance, we'll divide this lesson into 2 parts. One is your electric potential, next is your capacitance. Now, see, regarding capacitance, we'll do it totally separately. Electric potential, we'll do it separately. Firstly, for understanding electric potential, solving the questions of electric potential, you all, Deborah, Fadil, Fia, you all should have the concept of work done. If not, please write it on the top of the column of your register as electric work done and revise it and come. Whenever we have the next class, I think it has to be on Friday now, 6:30. So please revise this and come, because work done, integration, these will be used throughout. All right, if you people want, I can share the link also of integration with me. Just remind me once. Nextly, see what is meant by electric potential. We have studied electric field. What was electric field? See, in electric field, we had a source charge. This was a source charge that is present and is generating electric field around itself. Now, when a small test charge was brought from infinity to a particular point, when this was brought from infinity to this point and the scalar form, then we call it as potential. See, when just the charge was brought and the space around the charge that existed, that was called as electric field. Now, when you are bringing a test charge specially from infinity to a particular point, that is your potential. All the work that is done between this, that gets stored in the form of potential energy. Energy, we'll see that later. So it also defines the charge, but in scalar form. All right, so it's a very good point that we don't have to consider all the vectors and sign conventions for potential. If it is negative, subtract it. If it is positive, keep on adding it. And this is also property of a single charge. See, for forces, you require 2 charges, then only forces will be exerted on each other. For electric field, you require just 1 single charge that will be having a specific electric field around itself. For potential also, single charge is enough to generate electric potential. Okay, so these are all the basics of electric potential. A charge that is coming from infinity, you are specifically moving that charge from infinity to the particular point. All right, that is what is meant by electric potential. Now, a basic formula which you people have to remember. See, if 2 potentials are now generated, one is infinity from where the charge was kept, right? And one is the point, let's say A point. At A point, you have brought the charge. So what is the potential? Potential difference will be VA, that is the final point, minus V infinity, right? So VA minus V infinity. This is actually whatever is the total work done from bringing, whatever is the total work done from bringing that charge from infinity to that particular point. From infinity to that particular point. Work done for the charge, for unit positive test charge, you can say that's a different thing. So what is it? Potential difference is basically work done divided by charge. You can also define it like this. See, if charge Q becomes +1 coulomb. So if you put this as +1, It means a charge is kept at infinity. Infinity is what? Something that you will not be able to define. Very, very, very far away. Whatever is the literal meaning of infinity, that you know exactly that meaning only. You are bringing a charge from infinity to that point. Now a work done will be produced in the whole process. That is what we call in this infinity that we are defining right now. This is nothing different. These are all hypothetical topics only, right? Because you actually do not bring up a charge from infinity to a particular point. It's just a way to define it. So that infinity is exactly the same infinity which you already know, from infinity, far away, at the end point. All right. Now if charge is plus 1 coulomb, if I make this denominator as plus 1, then work done will be equal to potential. So what is the one more definition, which is one new definition, how to define in your registers, how to define in your exam sheets? Potential is the work done to bring a charge from infinity to a particular point, if and the charge is unit positive test charge. All right, unit positive test charge. So electric potential, it is the work done in carrying unit positive test charge from infinity to a point against electric field and without acceleration. Without acceleration, because this is against electric field, that's why without acceleration. Against electric field, this is actually written. Actually, this is written to a point against electric field and without acceleration. The scalar quantity SI unit is volt itself. All right, SI unit will be volt. Note it down from here, then I'll discuss rest of the things. Yes, Fadil. What do they mean by constant force and variable force? Constant force means the value of force is not changing. And variable force means the force is variable. X is there, T is there, this changing with respect to time, with respect to any position. Variable and constant, normal simple terms, that's only. It's not a different term. Variable force is the force that is constant. If I tell you force is 5 Newton, so that is 5 Newton only. It's constant, it's fixed. Variable force, F is, if I tell you that is 3x Newton, so it is changing with respect to position, right? So that only, with time, with position, with any variable, that is the same thing.
Okay, ma'am. Okay.
Again, the electric field acceleration, you forgot. Okay, we didn't do that part. No, that will come in current electricity. Acceleration will have electric field EE divided by M. So since we are doing against electric field, that's why acceleration, because of this formula. You were asking, no, what is the relation between acceleration and electric field? So this is actually the relation between acceleration and electric field. This will come in current electricity. Do not worry about that. One more thing, class. 1 joules per this, you can write this as joules per coulomb also. But 1 volt we only use. Rarely you will use joules per coulomb. All right, now the derivation part. See, a charge is there outside from infinity. We are bringing up the charge to this particular point for calculation. Forget this external also. Let's just have this external force. So from 0 to a point, from infinity to a point, we have brought it. Now the separation of from plus q, this is the source charge. Only this part of source charge I have drawn. This is a point. A point and separation between plus q, this is small r. Now separation between small q and plus q, this I am taking it as x. This is variable. Now the force will also be variable because distance is variable. Got it, Fadil? See, this was the difference. Now two types of forces will act. One force will be the external force through which you are bringing in the system, bringing in the charges. One force will be the coulombic force because plus q is also there, minus the small q is also there, plus q is also there. So one coulombic force will come into action. And if one coulombic force is there, one external force is there. So coulombic force will simply be k q small q divided by x square, right? Plus q minus q. What is the separation between plus q and minus q? X. What is the Coulomb's law? K q1 q2 by r square. So q1 is capital Q, q2 is small q. And what is the separation between them? That is x. So this becomes Coulomb's law. This is from Coulomb's law. This is the value of the force that you're having. Now, external force through the figure also, you already know this is acting in opposite direction. So this becomes minus F. Now this is variable because again, the distance is variable. The points of calculations are variable. So this is a variable force. So we cannot use Fs cos theta directly. F dot dx integration we have to use this time. So work done, dw also you can say, or work done also you can say. This is minus F. Why minus F? Because external is negative of it. So we'll use negative of it, right? Negative one only you will be using. Minus F dx. Now you are integrating it from where to where? You are bringing it from infinity to that separation R, to that point A. So infinity to R. Yes, from infinity to a particular point we bring it. That's what we call as potential only. That was the definition. Now put the value of F. This becomes k capital Q small q by x square dx from infinity to R. Now we just have to perform integration. That's why I'm telling you integration will be repeated in this lesson. Be clear with your integration. So work done. See, minus k, capital Q, small q, these are all constant values. What you are left with is 1 by x square dx, integrating it from infinity to R. Now see class, 1 by x square. When you differentiate 1 by x square, this becomes x to the power minus 2 dx. Instead of differentiating or dividing it by 1 by x square, this becomes x to the power minus 2. Now when you will integrate it, how do we perform integration? We add 1 in the power Now what's the power? 1 minus 2, right? So minus 2 plus 1, that you bring it here. So this becomes x to the power minus 1 by minus 1, right? X to the power minus 1, what we can do? We can make it in the denominator, that becomes 1 by x, right? This becomes 1 by x, and this minus sign is there. So what can I write? Minus k capital Q small q 1 by x integrate values from infinity to r with this minus sign. So this minus sign and this minus sign, they'll get cancelled. So we are left with k capital Q small q. Now put the upper limit first, 1 by r, right? We'll put the upper limit first. Then we'll put the lower limit, that is 1 by infinity. So, and 1 by infinity is 0. 1 over infinity is 0. 1 over 0 is infinity, and 1 over infinity is 0. So 1 over infinity, this is 0. So this term becomes 0. What are you left? We are left with k capital Q small q divided by r. This is the value of entire work done. So what is the value of potential? Potential was work done divided by charge. This is work done. So what is work done? Work done is k capital Q small q divided by r. And this q over here, q gets cancelled. Value of potential is kq divided by r. If you want, you can write the value as q by 4 pi epsilon naught r also. This is also valid. So force was Coulombic force, k q square by r square. Electric field is k q square by r. Potential is k q by r for point charges. Fine. Now potentials, I have told you, these are scalar quantities. So for positive charges, you will have plus q by 4 pi epsilon naught r. For negative charges, you will have minus q by 4 pi epsilon naught r. Write this quickly, the derivation for electric potential of a point charge for a point charge. This is important. This comes in your exam to prove what is the value, prove the formula for electric potential for a point charge, or calculate the electric potential for a point charge. All right, so this is important.
Ma'am,
Yes.
ma'am, can you please scroll up? I got disconnected. Ma'am,
Yes.
ma'am, whether the force is constant or variable, is it determined by looking at the distance, whether it is variable or not?
Whether the force is constant or variable, that, see, in this case you're asking, or in general you're asking?
In this case, ma'am.
See, in this case it is variable because we are continuously moving the charge. So displacement is variable. And if displacement is variable, your force will also change. See, if you just see, you apply Coulomb's law, you're getting F is equal to KQ by x square. F is inversely proportional to x. You increase x, you decrease F. So here you can analyze that force is inversely proportional to x, so it would be variable. Otherwise, in different cases, you have to analyze. In general, you have to see whether the force is changing with respect to a particular parameter or not. Like here we could see that it is changing with respect to displacement because of Coulomb's law, because of the properties of forces.
Okay, ma'am. Ma'am,
Yes. Who's asking? Fadil?
yes, ma'am.
Say?
Ma'am, here we are integrating because it is a variable force, right?
Yes, yes. Here we are integrating because it's a variable. If this was not a variable force, we would have directly written F dot S Fs cos theta.
Cos theta, right? Okay. And ma'am, also the previous class, my net wasn't very good. So can I just get the recording of the previous class?
Yes, yes. Okay, I'll then share on the group itself.
Okay, okay. Ma'am, I'm not there in the group.
You're not added, Fadil. Yesterday
No, no,
I
no.
asked you all who were not who are not added. Only Fia had responded. Now you are added, no
Yes,
Fia?
ma'am.
Okay, Fadil, I'll just text them to add you once. Okay.
Yes, ma'am. Okay, okay.
See, this question says minus 3 millicoulomb of charge is given and the separation to the point of calculation is 9 millimeters. So you have to calculate the potential at A point. So a very simple basic formula based question this is. And if this is a negative charge, you will get the answer negative only. Because when we had electric field, what did we do? We used to write it as the magnitude separately and direction separately because we had the concept of direction over there. So that time we could omit. But right now, this is everything. This is that there is no direction. So you have to write complete answer together. All right. So what is the formula? K Q by R. What is the value of K? 9 into 10 to the power 9. Charge is given as minus 3 millicoulombs. Class milli, it is 10 to the power minus 3 coulombs. And what is the separation? Separation is 9 millimeters. Separation R, this is 9 millimeters. So 9 into 10 to the power minus 3. So potential is 9 into 10 to the power 9. This is K. What is the charge? Charge is minus 3 into 10 to the power minus 3 divided by R. Separation is 9 into 10 to the power minus 3. So 9 will be cancelled. So this becomes minus 3 into, okay, this will also be cancelled into 10 to the power 9. All right, class. Now see one more thing. If you are having n number of point charges, so when we were talking about it is also superposition principle here in this lesson. See, when we were talking about the electric field, electric forces, all the vector quantities, what was the superposition principle that we used to apply? We vectorically added all the individual electric fields. We vectorically added all the individual forces. We practiced also a question based upon this, right? This is how we do it. So in electric potential, we don't have the concept of vector addition. We simply have the concept of directly you are adding the values because these are all algebraic quantities, these are all scalar quantities, so they just follow algebraic laws. So if one charge is present which is having k q1 by r1 as the potential at p point, second charge is present at this point p, it will be having k q2 by r2, at third point it will be having k qn by rn, till nth point we'll have k qn by rn. So what will be the net potential? Net potential will be simply v1 plus v2 added, directly added. If it is negative, so subtracted till be nth. That's all. This is your superposition principle in potential. So what is the superposition principle? For a system of n interacting point charges, electric potential at a point is the algebraic sum of potential due to individual charges. Now, one note point that is helpful for the numericals part. Sometimes though in the question this is asked work done by the electric field. Sometimes it is asked in the question work done by the external force. External force is what we have studied till now. Just in case if it comes against electric field. So I've told you know this entire experiment occurs against electric field. So put a negative sign for work done for electric field. That's it. All right. Let's see some questions also, some other questions. But before that, note it down. Then we'll see those questions. Last point, this work done by external field is equal to minus of work done by electric field. This means, see, what did I tell you the definition? See, here. So from infinity to a point, we are bringing a charge against the electric field, right? So when, if I ask you what is the work done, this is the work done we are calculating, we are talking about. When I say work done work done against electric field, when I say work done against electric field, so when we are talking about this work, if this is against it, so obviously it would be negative. If this means if electric field is towards the right, our work is being done, we are bringing the charge towards the left. That is the difference that arises when we say work done against the electric field. So that's why when we are calculating the work done for a particular charge, we write it negative for the electric field. External and electric field will be opposite. Like, try this question. Calculate work done by external force. This is saying external force in carrying electron from A point to B point. This is A point, 10 volt is written, B point minus 20 volt is being mentioned. So what should be the value from 10 volt to minus 20 volt? Work done is, and the charge is electron. So quickly tell me what should be the value of work done.
Ma'am, minus work done into electric potential.
See, when work done by external force is asked, carrying electron from A to B, what is the potential difference? That is VB minus VA. This is the potential difference. How do we write? Charge multiplied by the potential difference will give you the work done. So what is work done? Charge. What is the charge? Electron. Electronic charge, I've asked all of you to remember the value of electronic charge. What is the value of electronic charge? Yes, Fia. What is the value of electronic charge? Fia.
1.604 into 10 raised to minus 19.
1.6 into 10 to the power minus 19. The value of electronic charge. Now minus input because this is electron. What is VB? VB is minus 20 minus VA. VA is 10. So this becomes minus 1.6 into 10 to the power minus 19 multiplied to, this is minus 30. So answer will be plus 4.8 into 10 to the power minus 18 joules. Note down the second question. First note down the solution, then try the second question. See, calculate work done by electric field in carrying a charge from 2 coulomb from a charge of 2 coulomb from A to B. A is plus 5 volt, B is 15 volt. So VB minus VA, this is the potential difference. No fear. Charge is already given to you. Why are you using 10 to the power minus 19? Charge is already given to you 2 coulomb. See, this is the formula that we have to use to find out the work done by the external field. So this is 15, this is 5. And charge is 2. This is the work done by the external field. Fadil, no. Incorrect. Yes, yeah. Now your answer is right. Good. So this is 10. This is 15 minus 5. This is 10 into 2, which is 20 joules. So if work done by external force is 20 joules, then work done by electric field will be minus 20. So this is the answer. See, you have to calculate the potential at O point. So 4 points are given. Separation is A of entire point. Just take it individually. Like this is A point, this is O. So at O, you have to find out potential due to A. So one thing that we do not have is the separation, right? One thing that we do not have is the separation. But we have this entire triangle the right angle triangle we have. This is A, this is A. So if this is A, this becomes root 2A. So all the part AO, this is equal to BO, which is equal to CO, which is equal to DO. This will be root 2A by 2. So when you will rationalize it, this becomes A by root 2. So separation is A by root 2. Now talking about the first point. What is VA? Our general formula is KQ by R. Just keep this in mind. So this becomes K. What is the charge here? See, I didn't tell you to take the magnitude here. I have told you that take the entire charge as it is, because here directions are not going to come separately. In electric field, I used to tell you not to take the magnitude only. In Coulomb's force also, I told you Coulomb's law, take the magnitude only. Right now, you have to take the entire charge. So this is plus E. Separation is same, A by root 2. VB is minus E. So K into minus E divided by A by root 2. VC is K. This is 2E divided by A by root 2. Then we have VD. VD is K minus 2E divided by A by root 2. See class, if I add all of them together to get the potential at O, clearly you will see all of them are getting cancelled. See, when I say VA plus VB plus VC plus VD is the net potential. So that becomes KE by A by root 2. Then you have minus KE by A by root 2. Then you have plus K2E by A by root 2. Then you have minus 2KE by A by root 2. This will cancel this will cancel this, net potential is 0. So VO becomes 0. All right. Second part is also there, no? Work done in carrying, okay, E is not being marked. Let me tell you which is your E point exactly. E is a point that is given here. This point is E, which makes this as A by 2 and makes this as A by 2. This divides it. This is the point E. So you have to find the potential at point E. All right. So now forget other things. You just have to focus on this. So see, this is A. This is A by 2. For A point and E point, we have to find the separation. For D point and E point, we have to find the separation. BA, we already know. BE. BE is A by 2. Is someone asking anything? Is someone asking anything?
No, ma'am.
Okay. See, this is A by 2. This is A. So we have to find this separation. This is A by 2 and we have to find this separation, right? A by 2. So again, we'll use our Pythagoras theorem. So for the second part, it's like this is given to you. This is unknown, which you have to find. This is A. This is A by 2. So for AD, you will use under root. This becomes A square plus A square by 4. That becomes 5A square by 4 under root. So finally, you can say AD, not AD, sorry. AE. AE is equal to DE, which is equal to A by 2 root 5. So we have the separation now. Now again, we'll calculate the potential the way we were calculating. See, for E point due to plus E. At E point due to this charge plus E. K, Q will be plus E and separation we have just found. So VA will be K charge is E, separation is A root 5 by 2. Fine. VB. Point B has charge minus E. What is the separation to A point? This is just A by 2. So this time we won't be writing this separation. We have this separation different. So this will be how much? A by 2. So this becomes K into minus E by A by 2. VC. We have VC present. See, VC again, this is K. What is the charge? 2E. Right? What is the value of the charge that is present? This is 2E. Separation A by 2. So K into 2A divided by A by K into, you have 2E divided by, no, just A by 2. Then VD is there. So K constant will be there, K. What is the charge? Charge is minus 2E. And what is the separation? We have calculated using Pythagoras theorem. That is A root 5 by 2. So that becomes K. This was minus 2E divided by A root 5 by 2. Now we have these quantities with us. These won't be seen. What is the net potential at E point? It will be K 2KE by A root 5. 2, I am bringing it up. Minus 2KE by A. This becomes plus 4KE by A. I'm just bringing 2 upwards. This becomes minus 4KE by A root 5. Let's do one thing, class, to find out the solution of this. No, let's take 2KE by A common. That is common everywhere. 2KE by A. So what are we left with here? This is 1 by root 5. 2KE by A. This is minus 1. From here 2KE by A. So only 2 is left. 2KE by A. So 2 by 5. Minus 2 by root 5 is left. So this is our answer. This becomes velocity, this potential at E, this will become, this is 2KE by A, and 2 minus 1, this is 1. 2, again, 1 minus 2 is minus 1. So minus 1 by root 5. This is the answer. Last part is asking you to calculate the work done in carrying O to E. See, you have the work done for the first part. You have the work done for the second part. So third one will be charge. Work done will actually be charge multiplied by VE minus VO. E point and O point is being asked. So we'll use E and O. So how will we write this? Charge electron is there, VE. This is 2KE by A, 1 minus 1 by root 5. That's it, because VO is already 0. Fine. One graph, just keep it in mind. This is the last topic. This electric potential due to the point charge is also getting over. See, electric field is also KQ by R square, potential is KQ by R. So when you draw both the graphs, because this is more proportional, this has a power which is greater than 1. So this graph becomes steeper as compared to the graph of potential. So this comparison of graph is there in your NCERT. This can be asked to you. Note down this question quickly. Next weekend we'll continue. On Friday, most probably you'll have your extra class also. You'll be informed about the same. Okay, so if you people have completed, you can leave. Attempt your after class assessment today. Thank you so much.